Once again back to my YouTube channel Sriram Devarajan. Today I am going to solve another set of problems from KSET 2013 Mathematical Science question paper. This is my part 5 of KSET 2013. Already I have uploaded part 1, part 2, part 3, part 4 in my YouTube channel Sriram Devarajan. Kindly check the playlist of my YouTube channel. You may watch the videos of part 1, part 2, part 3 and part 4. Today in this video I am going to solve another set of 10 problems from KSET 2013. First problem: if C is the circle mod Z equal to 1, then the value of the integral over C, which is a closed curve, sin square Z by Z minus pi by 6 the whole cube into dz is option A 4 pi I, option B 3 pi I, option C 2 pi I, option D pi I. We have to find the value of the integral over C Z minus pi by 6 whole cube. Numerator is sin square Z dz. The circle is mod Z equal to 1. Solution: first of all, find the poles of f of Z by equating denominator to 0. Z minus pi by 6, which is equal to 0, Z equal to pi by 6. Clearly Z equal to pi by 6 lies inside mod Z equal to 1. By using Cauchy integral formula for higher derivative. Why I am using higher derivative? Because of power 3. Integral over C f of Z dz by Z minus A power n plus 1, which is equivalent to 2 pi I by n factorial f power n of A. Here A is pi by 6, n is 2, f of Z is sin square Z. I have to find out f double dash of Z and f double dash of pi by 6. This is equation star. What is f dash of Z? 2 sin Z cos Z, which is equivalent to sin 2Z. What is f double dash of Z? 2 cos 2Z. Now find out f double dash of pi by 6. 2 cos 2 into pi by 6 . This is 2 cos pi by 3 2 into 1 by 2, answer is 1. Therefore, star implies integral over C sin square z by z minus pi by 6 whole power 3 dz, which is equal to 2 pi I by n factorial means 2 factorial f double dash of pi by 6, that is 1. 2 and 2 factorial will get cancelled. Answer is pi I. For this problem, option D is the correct one. Second problem. The bilinear transformation which maps the points z equal to 0, 1, minus 1 into w equal to I, infinity, 0 is option A, I into z minus 1 by z plus 1. Option B, z minus 1 by z plus 1. Option C, z plus 1 by z minus 1. Option D, minus I z plus 1 by z minus 1. The problem is from complex analysis. We have to find the bilinear transformation. Bilinear transformation means it is of the form Az plus B by Cz plus D. Either by using formula we may get the answer for this problem, or otherwise in a quick way you may get the bilinear transformation. By substituting the value of z in all the option, we may get the answer for W. See, in this option, first one, I z minus 1 by z plus 1. I am substituting the first point z equal to 0. It becomes I minus 1 by 1. Answer is minus I. If I substitute z equal to 0, W value must be plus I, but I am getting minus I. First option, wrong one. That is option A. See, in option B and option C, there is no imaginary I. Therefore, option B, wrong one. Option C, wrong one. Therefore, now I am going to substitute the value for z equal to 0 in the last option. Option B, minus I 0 plus 1 by 0 minus 1. Answer is plus I. Similarly, I am substituting z equal to 1 minus I 1 plus 1 by 1 minus 1. It is infinity because denominator is 0. Last point, minus 1. Minus 1 plus 1 by minus 2. Here numerator is 0. Answer is 0. For z 0, I am getting W equal to plus I. For z 1, I am getting W equal to infinity. For z equal to minus 1, I am getting W equal to 0. For this problem, option D is the correct one. Third problem, under the transformation W equal to 1 by Z, the image of the circle mod Z minus 2i which is equal to 2 is option A, a circle, option B, a straight line, option C, an ellipse, option D, a parabola. Again the problem, the third one from complex analysis. We have to find the image of the circle mod Z minus 2i equal to 2 under the transformation W equal to 1 by Z. Whether image is a circle or straight line or ellipse or parabola. Solution. Since what is W? 1 by Z. What is Z? 1 by W. Z, since Z is nothing but x plus iy, W is nothing but u plus iv. Modulus of Z 1 by W minus 2i which is equal to 2, modulus of 1 minus 2iw divided by modulus of W which is equal to 2, modulus of 1 minus 2iw 2 times modulus of W, which implies modulus of 1 minus 2i. What is W? U plus iv which is equal to 2 times modulus of u plus iv, which implies 1 minus 2iu, I square is minus, plus 2v under the modulus 2 times root of u square plus v square. Since modulus of u plus iv is root of u square plus v square, here 1 plus 2v minus 2iu under the modulus which is equal to 2 times u square plus v square. For this modulus of 1 plus 2v minus 2iu, we can write it as 1 plus 2v square plus 2u square under the root which is equal to 2 times u square plus v square, square root of 1 plus 4v plus 4v square plus 4u square 2 times root of u square plus v square, squaring on both sides 1 plus 4v plus 4v square plus 4u square 4 into u square plus v square which is equal to 4u square plus 4v square. 4u square cancel, 4v square will get cancelled. 1 plus 4v equal to 0, v equal to minus 1 by 4. Under the W plane, This line is V, this one is U, this is W plane. Here we are getting V equal to minus 1 by 4, which is parallel to U axis. This is nothing but a straight line. Option B is the correct option. Now problem number 4. Let f of z, which is equivalent to 1 plus 2z by z square plus z cube, which one of the following statement is true. Option A, the expansion of f of z is 1 by z cube plus 1 by z square minus 1 plus z minus z square plus z cube for 0 less than mod z less than 1. Option B, residue of f of z at z equal to 0 is 1. F of z is analytic at z equal to 0. Option D, residue of f of z at z equal to 0 is minus 1. Again, the problem from complex analysis, f of z is given as 1 plus 2z by z square plus z cube. We have to check which among the following statement from the options A, B, C, D is true. See option B and option D, we have to find the residue at z equal to 0, whether it is 1 or minus 1, and also we check the function f of z is analytic at z equal to 0. See solution. What is f of z? 1 plus 2z by z square plus z cube. See in the denominator, z square plus z cube equal to 0. Take z square outside, 1 plus z which is equivalent to 0, z 0, z equal to minus 1. At both the point z 0 and z equal to minus 1, f of s is analytic. Here at both the point z equal to 0 and z equal to minus 1, f of z is analytic, but in the option C, f of z is analytic at z equal to 0. Option C, a wrong option. Now I am going to find the expansion of f of z, whether first option is the correct one. What is f of z? 1 plus 2z by z square plus z cube. Write this one as z square of 1 plus z, which is nothing but 1 plus 2z by z square 1 plus z power minus 1. This is 1 plus 2z by z square 1 minus z plus z square minus z cube plus dot dot dot. This is from the formula 1 plus x power minus 1. This is nothing but 1 by z square plus 2 by z into 1 minus z plus z square minus z cube plus dot dot dot. Now multiply, we get 1 by z square minus 1 by z plus 1 minus z plus dot 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 plus 2 by z minus 2 plus 2z minus 2z square plus dot dot dot. See, the first option is 1 by z cube, but you are not getting 1 by z cube. Option A, wrong option. Now I am going to check option B and D. From this term and from this term, how to find the residue? To calculate residue, if it is in the form of a series, the formula is coefficient of 1 by z in the Laurent series expansion, since we have to find residue at z equal to 0. Therefore, we are using the formula for finding residue if it is in the form of a series, coefficient of 1 by z in the Laurent series expansion. C, coefficient of 1 by z. Here coefficient of 1 by z is minus 1. Here coefficient of 1 by z is 2. Therefore, minus 1 plus 2, which is equal to 1. That is, therefore, residue of f of z at z equal to 0 is 1. For this problem, option B is a correct one. Problem number 5. Let f be an analytic function such that f of z, which is equal to 1 plus 2z plus 3z square for modulus of z less than 1 define sequence of real number a0, a1, a2 by f of z, which is equivalent to summation an z plus 2 power n then the radius of convergence of summation an z power n is option A 1, option B 2, option C 3, option D infinity. See, we have to find a radius of convergence for summation an z power n, but here one function is given in the form of f of z is nothing but 1 plus 2z plus 3z square plus dot dot dot. Define a sequence of real number a0, a1, a2 by f of z, which is equivalent to an z plus 2 whole power n. Here center is minus 2, here center is 0. First of all, what is f of z given? 1 plus 2z plus 3z square, which can be written as 1 minus z power minus 2, 1 by 1 minus z the whole square. Here singular point is 1. For finding a radius of convergence for this kind of problem, use distance formula. Radius of convergence nothing but center here minus 2 minus point, singular point is 1, minus 2 minus 1, answer is minus 3 within the modulus of minus 3, which is equivalent to 3. Option C is the correct. Problem number 6. The equation modulus of z minus 2 plus 3i, which is equivalent to 5, represent in the complex plane. First option, a circle with the center minus 2 plus 3i and radius 5. Option B, a line passing through minus 2 plus 3i and parallel to x equal to 5. Option C, a line passes through 2 minus 3i and parallel to y equal to 5. Option D, a circle with center 2 minus 3i radius 5. In the problem number 6, one equation is given in the form of modulus of z minus 2 plus 3i which is equal to 5. From the 4 option, which one is the correct one? Whether it is a circle with the center minus 2 plus 3i radius 5. B and C option, a line passing through minus 2 plus 3i parallel to x equal to 5. A line passes through 2 minus 3i parallel to y equal to 5. Last option, circle with the center 2 minus 3i and radius 5. Solution: given equation minus z minus 2 plus 3i which is equivalent to 5. This is in the form of modulus of z minus z naught which is equivalent to r, z naught center or radius. Therefore, modulus of z minus 2 minus 3i which is equivalent to 5. Therefore, this 2 minus 3i center, this one is radius. Therefore, see the option D, circle with center 2 minus 3i radius 5, which is a correct one. Problem number 7. Pick up the region in the following, in which the PDE y u xx plus 2xy u xy plus x uyy which is equivalent to ux plus uy is hyperbolic. Option A, xy not equal to 1. Option B, xy not equal to 0. Option C, xy greater than 1. Option D, xy greater than 0. One PDE is given which is a second order, and also given this PDE is hyperbolic in which of the region among the 4 options, which one is the correct one? Whether it is the region xy not equal to 1 or xy not equal to 0, xy greater than 1 or xy greater than 0. solution. Compare the given PDE with RR SS TT plus f of x comma y comma z p comma q, which is equivalent to 0. This R is uxx, this s uxy, this t uyy. And also the condition for hyperbolic s square minus 4rt greater than 0 for hyperbolic, less than 0 for elliptic, equivalent to 0 for parabolic. Here the problem is given hyperbolic. Therefore find s square minus 4rt. Here s equal to 2xy, r equal to x, t equal to y. R S T. Sorry, one error. R is here y. T is x. Therefore s square minus 4rt greater than 0 implies 2xy whole square minus 4xy greater than 0, which implies 4x square minus y square 4xy greater than 0, which implies 4xy x square y square greater than 4xy, which implies x square y square greater than xy, x square y square by xy greater than 1, which implies xy greater than 1. For this problem, xy greater than 1 is the correct option. Option C is the correct one. Eighth problem. Let alpha be a 0 of f of z of order m and pole of f of pi of z of order n m greater than n, then for the function f of z pi of z, alpha is option A a pole of order m plus n a 0 of order m plus n pole of order m minus n a 0 of order m minus n. Here f of z is given as a function with alpha be the 0 of order m, and another function pi of z which is a pole of order n with alpha be the pole which is of order n. For f of z, alpha is 0 of order m. For pi of z, alpha is the pole of order n with the condition m greater than n. Then we have to find the product of f of z, pi of z with alpha, whether it is a pole order of order m plus n, 0 of order m plus n, pole of order m minus n, 0 of order m minus n. Solution: given f of z 0 of order m, therefore z minus alpha power m with g1 of z, that is z minus alpha power m into g1 of z with g1 of alpha not equal to 0. And also given pi of z is a pole of order n. Pi of z is pole of order n means z minus alpha power n into g2 of z with g2 of alpha not equal to 0. Now find the product. F of z pi of z which is equivalent to z minus alpha power m g1 into 1 by z minus alpha power n into z2. Since m greater than n implies m minus n greater than 0, therefore z minus alpha power m minus n into g1 g2, both g1 of alpha and g2 of alpha not equal to 0. Therefore from this we can say f of z and with pi of z is a 0 of order m minus n. 0 of order m minus n, option D is the correct one. Problem number 9. The initial value problem, that is IVP, x into 1 plus x dy by dx which is equal to 2x plus 1 into y of x naught which is equal to y naught as unique solution if first option both x naught y naught is 0, option B x naught minus 1 y naught equal to 1, option C x naught is 0 y naught is 1, option D x naught 2 y naught 1. For this IVP, first of all find the solution. That solution must be unique with the condition y of x naught equal to y naught. The differential equation is x into 1 plus x dy by dx equal to 2x plus 1 into y. We have to check among the four options which option gives the unique solution, whether option 1 both x naught y naught equal to 0, option B x naught is minus 1 y naught is 1, C x naught 0 y naught 1, D x naught equal to 2 y naught equal to 1. Solution: what is given? X into 1 plus x dy by dx which is equal to 2x plus 1 into y. By the method of variable separable, write this one as dy by y which is equal to 2x plus 1 into dx divided by x plus x square. Now integrate. Integration of dy by y, which is log y. See, in this part derivative of denominator is in the numerator, therefore this one is nothing but log of x plus x square plus log c, which is nothing but log c into x plus x square, log m plus log n. This is log y, therefore y equal to c into x plus x square. Now I am going to check the option. First option, x naught equal to y naught equal to 0. Y of x naught which is equal to y naught which is equal to c into x naught square which is equal to 0 c into 0 plus 0. This is not possible since c belongs to R, which is infinite. Option A wrong option. Option B x naught minus 1 y naught equal to 1. X naught minus 1 y naught equal to 1. Which is equal to c minus 1 plus 1. This is 1 equal to c into 0, 1 which is equal to 0. Not possible. Not possible means no solution, but we must get unique solution. Option B wrong option. Option C. Option C, x naught 0, y naught 1. 1 C into 0 plus 0, again 1 equal to 0, not possible. This implies no solution. Option C, wrong one. Option D, x naught 2, y naught 1. 1 equal to C into 2 plus 4. 1 by 6, which is equal to C. Therefore, y equal to 1 by 6 x square plus x. This is for unique solution. Therefore, for this problem, D option is the correct one. Problem number 10. The minimum possible values of mod z square plus mod z minus 3 whole square plus mod z minus I whole square, where z is a complex number, is A 15, B 45, C 30, D 20. Solution. What is given? Modulus of z square plus modulus of z minus 3 whole square plus modulus of z minus 6i whole square where z is a complex number. We have to find the minimum possible value. What is z? X plus iy. Therefore, modulus of x plus iy the whole square plus modulus of x plus iy minus 3 whole square plus modulus of x plus iy minus 6i the whole square. Modulus of x, modulus means root of x square plus y square. Since it is modulus of x plus I y the whole square, therefore it becomes x square plus y square. It becomes x minus 3 whole square plus y square. It becomes x square plus y minus 6 the whole square. Let it take it as some function f of x comma y, which is equivalent to x square plus y square plus x square minus 6x plus 9 plus y square plus x square plus y square plus 36 minus 12y. X square, x square, x square. 3x square, y square, y square, y square, 3y square, minus 6x, minus 12y, plus 45. If we divide by 3, x square plus y square minus 2x minus 4y plus 15, some function f of x comma y. Find dou f by dou x. 2x minus 2. Dou f by dou y. 2y minus 4. Equate dou f by dou x equivalent to 0, which implies 2x minus 2 is equal to 0, 2x equal to 2, x equal to 1. Similarly, dou f by dou y, which is equivalent to 0, 2y minus 4, which is equivalent to 0, y equal to 2. Therefore, points are 1, 2. Substitute 1, 2 in star to get the minimum value. Therefore, minimum value is 1 square plus 2 square minus 2 into 1 minus 4 into 2 plus 15, which is equivalent to 1 plus 4 minus 2 minus 8 plus 15 . One error. To find the minimum value, we have to substitute x equal to 1, y equal to 2 in plus 45 plus 15, not in star, in 1. This is equation we are dividing by 3. Therefore, substitute both x1, y2 in 1, not in star, to get the minimum value. Therefore, minimum value is f of x comma y 3 into 1 square 3 into 2 square minus 6 into 1 minus 12 into 2 plus 45. This is 3, 4 into 3, 12 minus 6 minus 24 plus 45, 15 plus 45, 60 minus 30, answer is 30. For this problem, 30 is the correct answer. The option C is the correct option. Option C is correct option. This is a part 5 of KSET 2013 Mathematical Science question paper. I will upload and solve the remaining problems in 2013 KSET Mathematical Science. Subscribe my channel, share my channel to your friend and like my channel. Thank you.